Hey geometry students, trust each of you are doing well. I miss seeing you guys first thing in the morning, but trust you're doing great at home and enjoying this little extra break that you have. Let's go ahead and get started into our lesson for today. We're covering lesson 75, writing the equation of a circle. We've talked just a little bit about circles. We've talked about how to do tangents with circles and secants of circles and also chords and different things like that. But today we'll actually look at how to do the equation of a circle, and then based on that equation of the circle, we'll be able to graph our circle as well. Now, as we're looking at our lesson today, we're going to notice that there's two different equations that you can use when it comes to talking about a circle. And the reason that there's two different equations, it depends where is your circle centered when it comes to the Cartesian plane. The first equation I'm going to give you here today was where your circle is centered right at the origin on the Cartesian plane. If that is the case, you're going to follow the equation x squared plus y squared is equal to r squared. The only number that you're going to have to fill into this equation represents that letter r, which is going to be the radius. Notice there's no numbers on this side of the equation that involve the x and the y because the origin is that order point 0, 0, and there's no numbers that you would have to do to affect the x and the y in your equation. Let me show you how easy it is to use this equation here. If I asked you to write the equation of a circle, we know that it's centered at the origin, and we know that our circle has a radius of 9. Well, because our circle is centered at the origin, we know we want to use that circle format of x squared plus y squared is equal to r squared. In order to write the equation of that circle, just one simple thing we have to do, and we have to fill in the value of the r, or the radius that has been given to us, and notice I've done that for us. Our equation now says x squared plus y squared is equal to 9 squared, and then we just want to finish up with that arithmetic, giving us our final answer of x squared plus y squared is equal to 81. So it's pretty easy to write the equation of your circle if it is centered at the origin. In just a little bit, I'll show you what that format's going to look like if your circle is not centered at the origin. There'll just be two slight differences that we'll see as we're going to go ahead and write our equations. Well, one other thing that we want to do with our circles when they're centered at the origin is we want to go ahead and look at how do we correctly graph them as well. If I'm going to graph a circle, and we'll do the same thing with our second equation, there's two things that we have to know. The first thing that we have to know is where is our circle centered. The reason we have to know the center is because the second thing we have to know is the radius. We know that the radius is the distance from the center to the outside of the circle. So if I know where the center is, then I can adjust based on the radius to get to the outside of the circle. If you look at the equation, we see x squared plus y squared is equal to 36. Well, what do I know based on that equation? I know that the center is located right at the origin, 0, 0. I know that that is the case because I don't see any numbers over there with the x and with the y. What do I know about the radius? I know that the radius is going to be equal to 6. Now, how did I determine that radius? In our equation, it said r squared. So you want to ask yourself, what did you square to come up with the number 36? And that would be 6. So 6 squared is 36, which means our radius is 6. Notice on the Cartesian plane, I've already gone ahead and I plotted where is that center. I put it right at the origin of our Cartesian plane. Now, since the radius is 6, I can go in any of my directions, right, left, up, or down, of a distance of 6. And then I can draw my circle, and hey, it actually looks like a circle, not like something I would have to draw by hand if you guys were in class today. But you can go ahead and see that I went right 6, up 6, left 6, and also down 6 in order to come up with our graph of what our circle is in our picture. Now, the other thing that we'll be looking at, as I mentioned in our lesson, is what does the equation look like if it's not centered at the origin? If the equation is, or if your circle is not centered at the origin, there's two things that you're going to notice is going to change about your equation. And those two things are on the left side. Notice there's now parentheses on the left side of your equation, and we have x minus h squared plus y minus k squared is equal to r squared. The right side of the equation is identical. You still have the radius on the side by itself. Those two new pieces, the h and the k, are going to represent the center of your circle. Where is that middle point of the circle that we can adjust the radius from to get to the outside of our circle? Now, one thing I do want you to pay careful attention to here is that radius, we're going to see in our example, is going to, the center is going to be the opposite of what we see inside of the parenthesis. And I'll show you that in our example in just a second. So we have our center that's located at HK, and then we still need to know the radius in order to write our equation of our circle. Let's go ahead and actually look at one that I have the equation written for us already, and then we'll see how to correctly pick out the pieces of information. If I gave you the equation x minus 2 squared plus y plus 2 squared is equal to 9. Well, in order to graph a circle, there's two essential pieces that you have to know. You have to know where is the center, and you also need to know what is the radius. The first thing I want to pick out is the center. Now, as I just mentioned, the center is going to be the opposite of what I see inside of the parenthesis. In that parenthesis where I see x minus 2, that is going to give me the x for the center for our ordered pair. I see minus 2, that means for our center, I'm going to have to use a positive 2 for the value of x. Inside our second parenthesis where the y is located, I see y plus 2. Well, because it's y, that means it affects the y direction on the Cartesian plane. The plus 2, I have to do the opposite, and notice on my center, it's negative 2 for the y. I went ahead and I graphed it on the Cartesian plane by going right 2 and down 2 to get to the center of our circle. The second thing that I have to know if I'm going to graph my circle is I have to know the radius. Now remember, on the right side of your equation, it says radius squared. So what did I square to come up with the number 9? I had squared a 3. So from my center, what I'm going to do is I'm going to go right 3, left 3, up 3, and also down 3 to get to the outside of our circle, and I've connected those to make our circle on our picture. Let's try to go the other way this time. Now I'm going to give you the graph, and let's see if we can correctly write the equation together. Notice in my equation, it was called circle M, and I've labeled the center of our circle at M. Well, in order to write my equation, I know there's two things that are necessary. I need to know what is that center point, and I need to know how far from the center did I go to get to the outside of our circle. If I look at the Cartesian plane, I notice the center of that circle is located at 1, 3. Remember, to write an ordered pair, you go right or left first. So from the origin, I went right 1 space, and then you go up or down next. So after I went right 1, I then had to go up 3 to get to our center, and that location is 1, 3. Now from that center, I can go in any of my 4 directions, right, left, up, or down. How many spaces do I need to move to get to the outside of that circle? I need to move a radius of 3. Now that I know the center and I know the radius, we're going to look at that equation that it does involve a different center. Our x minus h squared plus y minus k squared is equal to r squared. To correctly write that equation, the 3 things I'm going to fill in are the 2 pieces from the center and also our radius. Notice inside of my parenthesis with the x, it now says x minus 1. Notice the opposite is inside of that parenthesis. We said the center was located at positive 1 for the x, so I put x minus 1 in the parenthesis. Inside of the y parenthesis, it says y minus 3. It's the opposite of what we had noted from the center for a positive 3. On the right side, I've correctly filled in my radius for 3 squared. Again, just finish up with that arithmetic. It's all on the right side of your equation, and our final answer would be x minus 1 squared plus y minus 3 squared is equal to 9. And I hope that makes sense. Again, just keep in mind that we always want to put the opposite inside of our parenthesis, or we're picking the opposite if we are asked to identify the center of our circle and we are given the equation. One last thing I just want to quickly go over with you guys with regard to our lesson this morning about our circles, and it's something that's called a concentric circle. Now, if you kind of even look at the title there, concentric. Well, the 2 key parts of our circle so far have been the center and it's also been the radius. Well, which one of these is it talking about? Is talking about the center. So what does that mean? That circles are concentric. They have the exact same center. They're located at the same spot on the Cartesian plane, but one of them is going to be bigger and one of them is going to be smaller. We have 2 different radii when it comes to our circle. We're going to notice as we go to write our equation here on our next example, the entire left side of our equation is going to be identical. Why would the left side be identical? Because that's where the center is located, and they both have the exact same center. The only thing that is different is going to be the right side, because that's where the radius belongs in our equation. Let's go ahead and take a look at that example, our final example for our lesson. It says that circle N is concentric with circle M. And that circle M is the one that we just did from our previous example, the one that had the center located at 1, 3, and it also had that radius that was number 3. Well, now our new circle has a radius of 5. So we just mentioned the center was located at 1, 3, just like it was for circle M. And here's our new radius that we have for circle N. The circle has a radius of 5. Because the circle is centered somewhere else, I'm going to use our equation, x minus h squared plus y minus k squared is equal to r squared. Correctly filling in our center and our radius. Again, the center I'm putting for the first parenthesis, I'm putting x minus 1, the opposite of that center. The second parenthesis, I'm putting y minus 3, again, the opposite of the y from the center. Correctly filling in the radius, we have 5 squared, and just neaten up that arithmetic. Our final answer giving us x minus 1 squared plus y minus 3 squared is equal to 25. Please notice I forgot to mention this so far. In between our two parentheses, between the x squared and the y squared, or even between these two parentheses, there's always going to be a plus sign. If it's a minus sign, then that leads us to another kind of shape that we'll talk about later this year. But please make sure that you do always put that plus sign, whether it's x squared plus y squared, if you're at the center, if the origin, or if your center had shifted, then you have those parentheses. But again, please make sure you put that plus sign between your two parentheses. If you have any questions on what we talked about here from our lesson, please go ahead and contact me, and I'll be glad to try to answer those for you. Give it your best shot with your homework, and I'll see you guys as soon as we can. Bye.